Okay. Now in this problem, I, so I guess they're telling you this is given. Yeah, there's no other way to do it. Okay. I mean, they're telling you the critical. This is you have to click the two-tailed, and then the critical values. I'm not sure what you enter here, but one of them. These are the two critical values, and then the test statistic is minus 1.225. So probably something like this ends up graphing or something like that. Or maybe it's on the outside. I don't know.
Yeah,
I might have to see your
it's
screen to see that. But what's bothersome here is like I don't see where it says like use comma to enter two separate values.
yeah,
Um,
on this it's a little different. It has like two boxes.
okay.
So I did the
Oh, okay.
negative
I
and
see.
then the
I see. Now
positive.
this is important here. This number is right there. So this
Yes.
is the in the middle here is the do not reject,
Do not
and on the right and the left is the reject and the reject. So in your problem here, you doesn't lie in the rejection region. And if it does not lie in the rejection region, it should not be rejected. So these always are paired together, these answers.
Mm-hmm.
And then if it does lie in the rejection region, then it should be rejected. Those always go together as well. So if you want to share your screen, I'm happy to sort of like watch you click through and maybe I can make more sense of this as well.
And then, yep, it was correct. It did
Oh,
like
good.
how you
Good,
said.
good, 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 good. Yeah. So hopefully the next one's like this. Maybe not, but we'll see. Um, maybe it's totally different. All right. So this one, see how there's the H one says greater than mu, which is a Greek letter greater than 8. Do you see that
Mhm.
next to H1? That means it's a right-tailed test. That's one-tailed. Right-tailed is one-tailed because of the greater than. And then they're telling you that so this one they're not giving you
Well, the
test
test
statistic.
value, right? I think that would be for it, or no?
No, oh, they are giving you the test statistic. Okay, so they're giving you 1.359 is the test statistic. And then p-value, go ahead and click on that fill tool, shade the, and then you want to click to the right of that. Um, no, that's not right. Oh, I'm sorry, that is right. Sorry.
Okay.
Uh, yes, it's to the right there. And so do they give you they give you the p-value 0.087, 0.087. So the p-value is that area in that tail. Okay,
Okay, I see.
let's scroll down just a little bit. Okay, let me grab a snip of just this part.
Okay.
And then could you just scroll up to where you can see in the top, oh, just a little bit, keep going up to the original question, sorry. See where it says the alpha, I'm sorry, 0.05 level of significance. Do you see that there?
Yes.
That's really, really important. That's called the alpha value. So let me go ahead and share my screen here. This is probably the most important thing you learn in the course. If the p-value is less than alpha, you reject H0. So in your problem, your p-value is 0.087, your alpha is 0.05. This is greater than, okay, which is not what I just said. So you do not. So if the p-value is greater than the alpha, you fail to reject H0. Like this is the only thing they want you to take away from the course. So in your problem, since the p-value is greater than the level of significance, the null hypothesis is not rejected. So that means this is like not rejected.
Okay.
And this is always true. Like this is always, always true. Like this is always something to remember. If the p-value is less than alpha, reject. If it's greater than alpha, you fail to reject.
Okay. Cool. Sounds good. Um, Let me share my screen. And that's correct. Just move this aside. Okay. And switch.
I'm not seeing your screen. If you want to try resharing real quick.
Could you see it now?
Still not sharing. I'm not seeing it. Let me go back and share my screen. Maybe that will make a difference on why we have this issue. Yeah, go ahead and try sharing again one more time. It's just showing me a black screen, which is
Yeah.
suggests you're not sharing the right window.
Do you see it now?
I'm just seeing a dark screen, which means I'm not
Yes.
sure what you're sharing.
Um,
So what to do here?
can you stop sharing? The other try
Yep,
again.
there you go. Stop. Now it's looks okay. If you want to try that one more time. Yeah, I'm just not seeing anything. Just a black screen. So maybe try sharing your whole screen or sharing the
Okay. Can you see the whole screen? Because I have it on the whole screen right
No, I'm not seeing anything here. So let me share my screen. Let me make sure you can see what's going on here. So what I have, like when I share screen, I have a little thing that shows me what the other person is actually seeing, which is you in this case. Like I can see that you're seeing this screen.
now.
And
Uh-huh.
I'm scrolling. Are you seeing kind of the problem we just worked on?
Yeah, I'm seeing all
Okay.
that.
All right. So
Is it
let me
because
do
I
the
have like two windows separated? Could that be the reason?
I don't know. Not much on the customer side. I mean, it's been working. So whatever you were doing to make it work, um, I would redo. So I've stopped sharing. Gonna
Okay.
I can also grab a few problems in a row if we need to. Yeah, just not working. Another thing you do here is just leave the meeting and re-enter it.
All right.
Just exit and then just click on that link one more time. Hopefully that will
All right. I'll do it really
resolve the
fast.
issue.
Okay. I tried it
All right.
again.
Okay.
So
Yeah.
put it in
Go ahead and
all one window
yeah.
to see if that makes a difference, I guess.
All right. Give that screen sharing a try. All right. So I'm seeing that window. Yeah, go ahead and hit the Alex tab. Yeah, that looks good. Whatever you did there, it seems like it's working.
Okay.
Okay. Left-tailed past. Okay. Scratch work not great. Okay, so we let me talk you through this one. Um, go down and click on one-tailed there.
Until, okay.
Oh, you can't do that. You can't do that way. All right, so we have to actually look these up. I see.
Okay.
All right, let me I'm gonna have to grab a snip.
I'm gonna
Can you scroll
see if I
down
can separate the
also?
window.
Just want to see if there's any past the scratch work not great. Okay, that's good. All right, let me share my screen. All right. So the idea here is it says left-tailed test, okay? And what's going on here is that we're looking for an area of like point zero one in the left tail. So there are these like Z tables that you can use. And I don't know if you're given one. I don't know if you're allowed to use a calculator. Um, I mean, just for for time's sake, I mean, I probably ought to just give you the values. Um, but we
Yeah, we
should
have the
eventually learn.
calculator on the side right here if I had to use it.
Okay. Yeah, because I don't want to I don't want to like and actually there's like there's tables, there's like you can look them up.
Oh,
Um so but the easiest way to do it is like in software. So the first one, and this is three decimal places. So for 0.01, it's minus 2.326. Sorry, that's the wrong decimal's the wrong place. 2.326. And so 0.05 is when, and there's a little bit more area. You can see that, it's all of this now. That's, 0.05. It's a little bit bigger. Okay. And this is just the area in the tail. And so normally these are to two decimal places. It's actually a little odd that your course is using three, but that's 1.645. And then 0.10, you're getting just a little bit more area in the tail, 0.10. So we'll at some point we'll figure out how you're allowed to look these up. Um, but this is minus 1.282. So those are the three values there. Those are the critical values. Is that okay so far?
so fun. And there's like I can look like at those online, those
Say,
tables you're
say,
talking
say
about.
that one more time.
I can look up like those tables online, the ones you're talking
Yes. I
about.
mean, or I can give you more information on how to find them, but like for now, let's just
Oh yeah.
skip through that. So now the idea here again, let me redraw this, is there are three critical values. There's the one at minus 1.282, minus 1.645, and minus 2.326.
Mhm.
And then the test value, the test statistic is right here at minus 1.738. So that fits kind of right in here. And the idea is that you reject only if this is beyond the critical value. So like for the first one, this is the do not reject, and then this is the reject. So since this value is less than this one,
Mhm.
you would reject it. So at the 0.1, you reject. Okay, well actually this is not rejected, so it's asking it backwards. Sorry, it's super confusing the way they do it. And then for the next one here, your do not reject region got bigger. Like this reject moves over here.
Mhm.
So for the second one, you would reject. But then for the third one, the reject is over here, and the do not reject got even bigger. It's now all the way to that leftmost line. So it's kind of a complicated problem, but the only one that would not be rejected is that 0.01.
More to the beginning.
And I know that probably isn't super clear, but maybe if we do another problem like it, it will be.
Okay.
Basically, if that number is below the others, then you reject. So it's like this. If your test value is less than your critical value, you reject.
Oh, okay.
So minus 1.7, maybe I keep getting the right number. Yeah, 738. Minus 738 is less than minus 1.282, so you reject. Minus 1.738 is less than minus 1.645, so you reject. But minus 1.738 is greater than minus 2.326, so you fail to reject or do not reject. So if you look back, this one says though not rejected, so we know it's reject, reject, not reject. That's why only that first one is selected.
Okay.
Whenever you're ready, if you want to share your screen again. All right.
And then something that's like
So that's not, yeah, that part's not great. It looks like you can
just reference off of it. Yeah. Okay. It's kind of
uh,
weird because when I was trying to type into that box, it didn't let me. So I'm gonna see what that's.
yeah, I don't quite understand that.
It's telling me to fill in the boxes, but like when I do it, it does not. It just
So I've
seems
seen
like
this before where you have to almost like go to the next question, then come back, or you have to copy and paste the numbers
oh
in
okay.
in there. Like it's an issue with
The new oh there we go. And then let's check that. Yes.
all right. So let's keep going here. All right, again, not to discourage you from doing them in order, but you don't have to do them in
In
order.
order.
So, but
Okay.
let me grab this
Yeah,
one.
so I know there's like so like there's gonna be more on the ones like we just did, so I'll try to do those ones so I have more of a reference for we
All right, let me share my screen here,
get. Okay.
and we'll get started on this one. So this is the first one where you have to like read the problem and figure out what it's saying. Um, so you're looking for a keyword like greater than.
Yeah.
That's your alternative. Mu is greater than 145. Okay. Which means that your null always has an equal sign. So I usually show this to students. If your null or your H0, if your null or your alternative, these just pair together. Equals goes with not equal. Greater than goes with less than or equal to. Less than goes with greater than or equal to. These are just standard, like this is always true. You don't have to look this up. So if you're ever unsure, that's how you figure out this part. Um,
Okay.
now, how did it kind of tells you mu is 145, mu is greater than 145.
And the mu is the U, correct?
Yeah, now it's possible that they want you to put an equal sign here. I'm not exactly sure. It depends on the course, uh, which you might wonder why, but hopefully it's not. If it's not, the other option is that this first one will be a mu equal to 145. That's a oddity of this. All right. So this is talking about what's called type 1 and type 2 errors. And suppose that so there's two, let me go ahead and grab you a reference for a type 1 and type 2 error. So the type 1 error, I'm going to word this correctly. Just trying to find a reference here. All right. So a type 1 error, let me get this on the screen here. There's specific words you're looking for. You reject the null hypothesis, but it's actually true. So you say like no, it's not true, but it actually is true. That's a type 1 error.
Okay.
This is sometimes referred to as a false positive. A type 2 error, and actually they use Roman numerals for these. I don't know why they do, is when you fail to reject H0, the null hypothesis, but it's actually false.
Okay.
And maybe being in the medical field, you know about some of these things, false negatives and
False
false
positives.
positives. Okay. Um, So rejecting the null hypothesis, but it's actually true could be bad. Failing to reject, but it's actually false. I mean, these are also potentially bad. So in your problem, I don't know what's in the drop down, so we'll probably have to
Yeah, type
look
1,
at
type
this. Yeah. So you do not
2.
reject. So that's the second one. You fail to, no, sorry. You decide not to reject. What are the options of drop down? Is it type 1, type 2, and none?
No, it's just type 1 and type 2.
Yeah. So that's a type 2. Type 2 is when you fail to reject, is what happens when you do decide. That's for that one.
It's a little different, like how it's worded. I can see.
Okay. So type 2 error would be, like I said, failing to reject the null hypothesis. You do not reject the null hypothesis. That
Yes.
mu is, and I don't know what goes in this drop down, so you might want to
Uh, it says I can
share.
read it to you, or should you give
Yeah,
it
why don't
back?
you share? I'll do better seeing it. Um,
So,
uh, boy. So, all right. I want you to change H0 to mu equal to 145. They're in the, yeah, because it is kind of worded that way. All right. Uh, Failing to reject the hypothesis that mu is equal to, so we're just grabbing the null hypothesis, 145,
oh, okay. Now it
when
makes sense.
when in fact it actually is greater than 145. So you don't reject it, but it actually is greater than.
Mm, yeah, I get it now. Mom.
Okay.
Before I was like struggling so hard on
It's
that,
a little
and
odd, yeah.
yeah. Um, is this the same one kind of that we've done, or is it
Kind
like?
of, you have to write your own H0 and H1.
Oh, okay. Mm,
So if you read the wording, it says now less than 24. See where it says mu in the third line. Mu is now less than 24.
oh yes, right here.
That's the alternative hypothesis. That's mu less than 24.
So that would
That's H1. Yeah. Sometimes it's easier to do H1 than,
and you said it was a less than, right?
yes, yes, now less than. So now it says their visit is 24 kilometers. So we'll go mu equals 24 for the first one for H0.
Equals to 24, you said?
24. So the numbers are always the same in the null and alternative hypothesis. Now the direction in the alternative, the H1 tells you whether it's one tail or two tail. Since it's a
Mm-hmm.
less than, that's one tail.
So critical, so would that would be 0.05.
Well,
Oh no.
no. So no. We have to go back up and look at the alpha level. So we're looking for the significance level. See where it's a 0.05 level of significance?
Mm-hmm.
That means that it's that minus 1.645 that we got earlier, minus 1.645.
From that list
Okay.
that we were.
All right. And then to get the test statistic, they're showing you that formula there where it's a z equals x bar minus mu over sigma divided by square root of n. Do you
Mm-hmm.
see that formula there? So we want to go back and grab those values from the actual top there. So the 24 is the mu.
I'm going to use
Okay.
that for you.
That's the mu. So your X bar is the sample mean. Do you see the sample mean in the last sentence there?
Yeah, so sample would it be the 23.1?
23.1. Yeah, so this is where you want to maybe grab your calculator there on the right and type a fraction bar. Yeah, and do 23.1 minus 24 in the top. And on the bottom, put another fraction bar.
Another fraction term
Yes, so your standard deviation,
is
and you
4.
find that in that lesson, 4.4, divided by the square root of the number of visitors.
So square root and then 43.
Yes, there you go. So calculate that,
And then negative,
and then make sure you round minus 1.341.
yeah,
Okay.
15, so
So see how that's not in the shaded region? It's in the do not reject region. Do not reject region. So uh, we're looking for the answer that says the null hypothesis is not rejected. So that's either
I would say
B or D. And then there's, let me just read the differences.
does not lie.
Okay. So the last one is correct. Since the value of the test statistic does not lie in the rejection region, does not lie in the rejection region, it's not rejected. You'll notice that's the difference between B and D. Hopefully that's somewhat clear.
It was
Yeah,
when I was doing some of it, like I was getting like some of it right, but when I got to this question, I got real thrown off with like this
sure.
part.
Hopefully you see where all those values come from now.
Yeah. Let's see if I can find a different one because I know majority of them like are the same. Like this one,
This is the same.
yeah. Um, this one
We,
I think is a little different than the last one because it has three, two more of them than E and the D.
let me grab a snip of this one, and
Okay.
you can always say, "Hey Matthew, I know you can talk me through it, but give me a snip of it.
Okay.
You're the customer. You're always right."
You're fine.
Here we go. So you can read all this, but really you're just looking for the numbers, um, and the numbers they all mean something. It depends. I mean, there's some duplication there, but we're looking for where it says something about, do we think um, do we think that it's gotten better or worse? It says here to perform a two-tailed test, so we know that it's a mu not equal to. That's a two-tailed test. The not equal to is always that. And the claim is that it's 54. If you remember from earlier, this is always paired with an equal to.
Yes.
Now, can you tell me what's in the drop down?
Yeah. So for the drop down, it says it's Z T F and then Q.
Oh boy. Okay. So
Yeah.
so this is now more confusing, and I hate that they're doing this to you, but there's this population standard deviation. That's a z-test. If it said sample standard deviation, that's a t-test.
Well, that's good to know.
Yes, very important in this part of the course. All right. So now, because it's a two-tailed test, you take the level of significance, alpha is 0.01, but you divide it by 2 because it's two-tailed. So alpha is 0.005 in each tail, and you have to look up that value. So I'm going to do that for you. Um, so it's and there's two of them.
Oh,
Sorry, that's the critical values. That's down here. So it's minus 2.576, or and 2.576.
so it just literally just took a negative off.
Yep, yep. All right. And then to actually find the value of the test statistic Z, that's the X bar minus mu over sigma divided by the square root of n. That's where you got to go back and find the value. It's 55 minus 54 over 8 divided by the square root of 50. So, because I do this all the time, I can find these pretty quickly, but that's what you're looking. You have to be able to identify those. And they say all the words in there. They say the sample mean, population standard deviation, the number of samples.
It's just looking for like the words. And I try to do that now too. And that's
It's hard to do. I mean, you're probably doing better than most, but that's a very difficult part of this. So, um,
and for my answer, I got 0.883. So this is
so
around
it rounds up to 0.884.
884.
And so this value, if we were to just draw, kind of this here, um, here's minus 2.576, here's 2.576,
Mm-hmm.
and 0.884 is here. This is in the do not reject region. And then each of these over here on the sides, those are the reject regions.
Okay. That's more clear to understand. So it's in the
Yeah.
so the answer I would say is no.
So differs, yeah, the answer is no.
I'm gonna see if I can find a different one really fast.
All right. Okay, let me grab a snip of this. We want to conduct a hypothesis test that the population mean number of holding penalties during a college game is less than 3.1. Okay, so we choose a random sample of games. Samples a mean of 3 penalties per game. The standard deviation is 0.7. So the mu here, all right, mu is sorry. The mu here is the mu value is the 3.1. That's this first one. The sample mean, the X bar is 3, and the standard deviation is it's really S because they're not telling you whether it's S or sigma. I guess we could put it that way for now. And then for part A, the N equals 20. Okay. Um, so now okay, I see what they're trying to do here. So since it's an unknown, and they really mean unknown population standard deviation, um, that's when you use a T. And T is X bar minus mu over S divided by the square root of N. So the only difference between that formula and the one we just did is the S versus the sigma. So that's the 3 minus, sorry, it's the, 3 minus 3.1 over 0.7 divided by the square root of 20. I'm not sharing, am I?
No, it's
Okay.
okay.
I realized I'm not sharing, and I'm talking through this as if I am. I super apologize for that. You
It's
missed.
okay, no worries. I kind of
So
understood it for the most
yeah,
part.
yeah. So the thing here is like they're just trying to get you to decide whether it's a Z or a T, and because it's an unknown population standard deviation, that's why it's a T. Now in the next problem, when it says a known standard deviation, that's when you go back to Z. The known part means, okay, we can use sigma. Sigma is the Z. Sigma is the population standard deviation. So we have to calculate this first one though, this three. It's
Yeah, so I got negative 6.388, but since the seven's bigger, it would be 9. So it's
let
negative.
me yeah, so I got minus 0.639.
Yes.
Okay. Now for the Z here, it's the same formula, but instead of S, you're using what's called sigma, but they have a different sample size. So it's 3 minus 3.1 divided by 0.73 divided by the square root of 14. So just some small changes to that formula you just did. What I'm hoping, the sample size is pretty small, but that shouldn't
Mhm.
matter. Like it shouldn't matter at all. That should work. So I think that's everything on that one.
Okay.
Sorry, that goes in that goes in the Z box. Yeah.
Oh. Mm. Um, so the next question is the correct.
So whenever you're ready, if you want to share your screen, I can take a look. All right. Oh boy. Um,
Yeah. Important.
more here. All right, I'm gonna need to take two snips, so let me grab the first one. All right, could you scroll down to part B with all that? Yeah, keep going down, 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 right? Go down even further, right? Just to the top of that. Right there's good, yeah. Um, hopefully. Oh, I guess I better grab a third snip. All right, if you want to scroll down all the way, I can grab the last little bit. Okay. I need to show you how to snip stuff, and then you don't have to. We'll go even faster. But
Okay.
I'll maybe do that next time. It's
Okay.
really easy to do. I mean, it's just it will save 10, 20 seconds every time. So, all right, a lot of words here. Um, so the key one here is more than 12.1. So that's mu greater than 12.1. Um, the I'm looking to see if they, yeah. So the null is equal to 12.1. Apparently, your course is using this whole idea that the null is always an equal, and the alternative could be a not equal to, a greater than, or less than. That's what that appears to be pretty consistent here. Um, so the x bar is 12.4, S is 1.2. The reason it's S is because it's a sample standard deviation, and then N is 29. So you have to be able to extract all that from this
From there.
top part. All right, now um, the T, you got to find the T. The T is 12.4 minus 12.1, 1.2 divided by the square root of 29. We'll need that number. That's the step three value. We'll need that for down here. All right, so I got 1.34 6. That is that what you got?
Um, no, I got something a little different. They gave me
Okay.
50.2615.
All right. Let me check another calculator I use, see if there's any differences. Make sure you got, make sure you got that fractions in the right place and all that stuff. And
Oh, yeah, I
um,
don't have the parentheses in place, so maybe that makes a difference.
yeah, I'm getting 1.346, which I feel pretty solid about. So just double check yours. So the degrees of freedom is always n minus 1. So in your problem, it's 29 minus 1, which is 28. Because it's greater than, it's a one-tailed test. And then I'm not sure exactly what it's going to draw here, but
Yeah, it's in line.
yeah, sorry, that's not what we want. So yeah, so you're gonna put this in. This is your p-value over here. Make sure you shade it there, and then whatever number shows up in there, you can do that. I'm gonna also do it as well. 1.346 degrees of freedom or 28. All right, so I got 0.095, but use whatever value. It should be really close to this.
Doing for that, for the step five, the same value, like the same.
Why
Uh,
don't you share your screen? I'm concerned maybe you're getting something different. Um,
yeah, uh, I just got a little thrown off when you were going so fast, so she was like everything that at once.
yeah. So your shading is fine. It's so sorry. Up there in the top, 12.4 minus 12.1. 12.1 is why you're having the different number there.
Oh, oh.
There you go.
You don't need the
You
parentheses, or
don't need no, you don't need that parenthesis. You can remove it, or I don't know if you can backspace it or what, but up, maybe undo that. Maybe just add it
just do it.
on the bottom or restart. Yeah, or add it there on the bottom as well. Okay,
There we
there
go.
you go. All right.
And then, so I got thrown off when you were saying from
Yeah,
that.
I mean, can you just click in that blue area on the right? Like, will it just tell you
No.
or maybe remove your calculator? Maybe it's in that where you can't see it. So I got 0.095. I'm surprised yours doesn't like tell you it.
0.95.
Let me share my screen so you can see that. It's as 0.95. Um, I'm really surprised. Okay, but anyway, I mean that's all right. So the p-value is over here. It ends up being 0.095. Now, 0.095 is less than 0.10, so you're going to reject H0. So we're looking for the one that says p-value is less than. So it's not those. Less than. Okay. Which means that the null hypothesis is rejected. So this one says is not rejected. So you just have to look really closely at the wording. Whenever it's less than, you reject H0.
Awesome.
All right, see if we can quickly get another one done here.
Hold on. Let me see if I can find one of that. It's different. Okay. This is so simple.
Let me grab a snip of this.
Just tell me when you need
Okay.
to scroll down.
All right, so go ahead and scroll down to the top of that normal curve. Yeah, right there is good. I'll get the rest. All right, so first things first here, go ahead and share my screen. So the first sort of table that you got here,
Mhm.
there's let me go grab one from the internet. These are there's like really well known um tables. So uh like I don't know what's in the drop downs, but there's a bunch of pictures that I'll put in here.
It's just
Here's
saying like on the top, it's like HO is true, HO is false.
okay. So there you go.
Okay.
Here's the
Oh,
mapping of it. Type 1, H null is true, false, rejected, not rejected, something like that.
yes.
Okay, now for the next one here, how do we know whether it's a one-tailed or two-tailed test? Okay, so this is two-tailed
Mhm.
because of that. So because they're not equal to, so that means we're down here. And your test statistic is 2.152. So the that's like here and here, and then you're shading over here and here. And so I'll get you that p-value. It's your p-value ends up being 0.031, 0.031. And then what's our level of significance? Where does it say that? 0.05. You always got to go and look for that. So 0.031 is less than 0.05, so you reject H0. The null hypothesis is rejected. The true proportional odds result or when is 20% is the result. Um, so uh, the null hypothesis is rejected, but we find that the null hypothesis is actually true.
Uh-huh.
So when you reject the null hypothesis, but it's actually true, that's a type 1 error. Reject H0 when true. So I'll definitely send that over in the notes here. We do have to stop for